Welcome to our next homework review video for Year 5, and this is going to focus on the tasks that were set for week 2. The tasks come from the Collins 11 Plus Maths, Arithmetic and Word Problems Support and Practice Workbook. So let's just have a little look at the homework overview just so we're clear about the topics that we're going to be covering. So we're going to be focusing on perimeter and area. We're going to be looking at angles, and we're also going to focus on BIDMAS. Now, in actual fact, the BIDMAS pages 41 to 42 will come first, followed then by the angles, and then we'll be looking at perimeter and area. So let's have a look at the BIDMAS section, or what we call the order of operations. Sometimes it can be referred to as BODMAS, but in this instance we're going to talk about BIDMAS. If you are given a calculation with a mixture of operations, it's important to follow a rule. This rule ensures that you do the operations in a certain order. If the operations are not carried out in the correct order, then the answer will be wrong. BIDMAS gives you the order in which operations should be carried out. Remember, BIDMAS stands for. So we're going to go through each of those letters now. So the B stands for brackets. If there are brackets, work out the value of the expression inside the brackets first. Then this is followed by indices. This includes powers such as squared or cubed numbers, or square roots or cube roots as well. The next part of BIDMAS is division. If there are no brackets or indices, then you do the division next. Multiplication actually has an equal importance to division, so work from left to right to decide which to perform first. Addition, if the expression only has addition and subtraction operations, then work from left to right, because they have addition and subtraction have equal importance again. So subtraction, again, as I've just said, has equal importance to addition, so work from left to right to decide which to perform first. So there were a couple of examples within the students' books. So just having a look at those first of all, just so we can be clear. So the first thing we would do, if we have a look at the example here, example 1, we do have a set of brackets. So therefore we would do that calculation first. So jottings are really important here, so I would actually write the 2 above, because 6 divided by 3 gives me 2. And then we can write out the calculation again. Remember, with addition and subtraction, they have equal importance. So we're just working from left to right. So 3 plus 2 is 5. Take away the 1 gives me 4. Example 2. So in this instance, we know that the multiplication needs to be done first. So I'm going to write 10 here. Now we're going to work from left to right. So 3 plus 10 gives me 13. Minus the 1 gives us 12. Example 3 is a little bit more complicated. We've got a set of brackets, so we must do that first. So 8 plus 2 is 10. And you might remember the I stood for indices. And if we look at the 2, we've got 10 squared, which of course makes 100. And then we're going to do the multiplication part. So 4 times, and we've been given 3 squared. So 3 squared, of course, is 9. So then we do 100, take away 4 times 9. 4 times 9, of course, is 36. So 100, subtract 36, leaves me with 64. So as Billy says, BIDMAS is a bit like baking a cake. You need to know what order to add the ingredients. Let's go and have a look now at the develop section. So there were 10 questions here to work through. And again, we need to follow BIDMAS. And I've just got here in the top corner just a reminder about what BIDMAS stands for to help you with those order of operations. So looking at number 1, the first thing we're going to do is actually do the indices. So we're going to focus on 4 squared. So 3 times 4 squared means that 4 squared will give me 16. So we need to do 3 16s. something you might be able to do in your head, is 48. Question 2, we need to look carefully now at the brackets. So 4 divided by 2 gives me 2. Now we're going to follow through the operation from left to right. So because we've got the division first, we're going to do 30 divided by 2. That's going to give me 15. Add the 3 is going to give me 18. Moving on to number 3. Now we've got division, but we've also got the indices, the squared sign. So we're going to do that first. 2 squared, of course, is 4. Now I can complete the rest of the calculation. 20 divided by 4 leaves me with 5. Now in number 4, we've got addition and division. So it's actually the division that comes first. So it's 24 divided by 6 is 4. Now we do 7 plus 4 to give me 11. Number 5, we've got the brackets. So we're going to do 16 divided by 8, which is 2. Now the next part that we need to work out is actually the multiplication. So we're going to do 2 times 3 is 6. And then we've got 2, in actual fact, with that one, we will need to go back. Sorry, I missed the little 2 there. So 16 divided by 8 is 2. Then we do the squared to give me 4. Then we do 2 times 3, which is 6. And then 4 add 6 gives me 10. So I just missed the squared sign there. Number 6. Again, we've got brackets, so we must do that bit first. And we've also got, inside the brackets, we've got the indices. So 5 squared gives me 25. And then take away 4 squared, which is 16. So that will give me 9. I can write 9 above. And then 3 times 9 gives me the answer of 27. Moving on now to question 7. We've got 12 take away 4 is 8. I'm going to do the brackets first, of course. And then 40 divided by 8 gives me 5. Now in question 8, we've actually got 2 sets of brackets. So it doesn't really matter necessarily which one we do first, but we are just going to record our answers above. But we're going to work from left to right. So 3 plus 9 is 12. 3 plus 1 is 4. Now we can use the middle operation, which is division. 12 divided by 4 is going to give me 3. Question 9, we again have our brackets. So we're going to do what's inside the brackets first. Now this says 2 cubed. So just to be aware, it would be 2 times 2 times 2, which of course gives us 8. So we're going to write 8 above. And then it says 8 times 1, of course, is 8. Now I'm actually going to write this calculation out again. So we've got 2 plus 8 times by 4. So in this order, we need to make sure that we do the multiplication first. So it's 8 times 4 is 32. And then we add the 2. Now interestingly with that one, as with quite a few of these calculations, if we did it the other way round and we did the addition first, 2 plus 8 is 10 times 4 is 40, so you get a completely different answer. So it's really important that we do follow BIDMAS. So the answer to number 9 is 34. Moving on then to question 10. So again, we've got brackets, so let's deal with that first. 3 plus 1 squared, well of course 1 squared is 1. And then we're going to need to cube that answer because we've got a 3 on the outside. So if we write this out again, we've got 2 squared, which is 4, times, in the brackets, we ended up having 4. And then we're going to need to cube that answer. So 4 cubed gives me 64. So we need to work out 4 times 64. So 64 times 4, you might like to do it like this. So 4 4s are 16. 4 6s are 24. Add the 10 on. So we get 256. Now the last part of this particular page involves you working out what operations to put where the stars are located. Now this will involve quite a bit of trial and error. Just to be clear, the expressions are correct by replacing the star with either addition, subtraction, times or divide, and using brackets if required. So an example here is 3 star 7 star 2 equals 20, and it becomes 3 add 7 is 10. That's the bit you would do first, so you can put brackets around that, multiplied by 2. Then a slightly more complicated one, 5 star 8, 8 star 2, 2 star 4, 4 star 3 becomes 6. So in this instance, we need to put brackets around the 8 and the 2, make that multiplication, so that becomes 16. Now remember, in our order of calculations, we're going to need to make sure that we do the division first. So you do 16 divided by 4 is 4. Now, with the add and subtraction, because they have equal value, we're going to work across. So we're going to do 5 plus 4 gives us 9. Take away 3 gives us 6. So these are good fun to have a go at. Again, you might try lots of different things. I'm just going to show you what the answers are now, and hopefully you've been able to get the right answer. So the first one actually has 2 potential answers. 4 star 2 star 8 equals 10. So again, with trial and error, you can try different things out, but you could have a take away sign and then an add sign. Remember, they're equal value. So you could say 4 take away 2 is 2, add 8 gives you 10. The other way to do it is to replace the subtraction with actually a division sign. So it becomes 4 divided by 2 is 2 plus the 8 is 10. So it's entirely up to you which way round you do that. And again on B, once you've played around a little bit with the operations, we've got add, times and take away. So it's important that again you do these in the right order. So we're actually going to focus on the 4 times 6 first. So that gives me 24. We're then going to add the 5 to give me 29. And then finally 29 subtract 8 leaves me with the answer 21. Now it might be the first time you do these questions, you're not necessarily going to get all the right operations, but a bit of trial and error, trying different things, trying to get to that right total, I'm sure you'll get there. On C, it's add, then divide, and then times. So in this instance, because remember we've got the division and the multiplication, they're of equal value, and then we're going to do the addition. So in this part, what we can do is actually bracket the 6 divided by 3 to make 2. Just going to write it out again. And we know we need to do the multiplication first. So I could put the brackets around that. So 2 times 4 is 8. Then add the 2 to give me 10. It's quite useful having BIDMAS there. Again, just try and learn that order off by heart. Keep practicing it. Keep reminding yourself on what all those letters stand for. And the last one, we've got 1 add, and we're going to put 3 and 8 in brackets, divided by 6, take away 2, gives us 3. So let's do the brackets first. So 3 times 8 is 24. So again, I'm going to kind of write it out again so I've got it very clear in what we're doing. So the next part would be to do the division. So you're going to do 24 divided by 6 is 4. And then we've got 1 plus 4 take away 2. So 1 plus 4, we're just going to go from left to right, is 5, take away 2, leaves me with the answer of 3. The next part of this video is going to focus on lesson 22, which is the angles section. This is on page 110. So just having a look at the learn section, and this certainly is worth reading through. So first page just looks at the types of angles. So it's worth noting that within the GL assessment exam, you will have no mathematical equipment. Therefore, it's important that you recognise the main angles, as you are unable to use a protractor, of course, to measure them. So the size of the turn determines the type of angle. So below are some examples. So we've got the acute angle, and this is less than 90 degrees. It shows the obtuse, which is bigger than 90, but less than 180. The right angle, a straight line, or a straight angle, which is 180, the reflex angle, and then a complete angle. So it shows there the 360 degrees. Let's go and have a look now in a little bit more detail into that. So before you do your exam, it's a good idea to learn the main angle names. For example, a question might be, what is the name for an angle of 112 degrees? So an angle less than 90 is referred to as acute. Always think about that word acute as in being small, something cute that you might stroke. An angle more than 90 degrees but less than 180 is called an obtuse angle. An angle greater than 180 is called a reflex angle. And then an angle of 90 degrees is called a right angle. Two angles that add up to 180 are called a supplementary angle. And then two angles that add up to 90 are called a complementary angle. So just revising that, maybe writing it out, maybe drawing different angles to represent those different names will really help you. An angle then, example of 112 degrees, is between 90 and 180. So we'd call this obtuse. One of the other things which is a good thing to learn about is what we call interior angles. So these are angles inside the shape. The other important facts to remember when learning angles are the interior angles of different shapes. And what we can do is we can use a formula to help us work that out. So I'm just going to go through and give you an example here. So the way we work out the interior angles of a shape is we do n take away 2 times 180. Now we just learned in the previous part of this video about brackets, so we do that bit first. What does the n represent? Well, it's the number of sides of the shape. So let's talk about a triangle. We know, of course, that that has 3 sides. So I'm just going to draw out a triangle here for you. So with that triangle, these interior angles all add up to 180. And the way we can prove that with this formula is to say, well, n has 3 sides. 3 take away 2 is 1. 1 times 180 is 180 degrees. Now, it actually doesn't matter what sort of triangle you have, whether you have a scalene, whether you have an isosceles, an equilateral triangle, or a right-angled triangle, all the angles will add up to 180 degrees. Now, this example here goes through in the learn section, talks you actually about quadrilaterals and how you would work that out. So we do exactly the same as we did with the triangle, but of course, quadrilaterals have 4 sides. So we do 4 take away 2, gives us 2. 2 times 180 is 360 degrees. And any quadrilateral, a trapezium, a rectangle, a square, a rhombus, parallelogram, all the angles inside will always add up to 360. So what you might be asked to do in the exam is actually work out the missing angle in a shape. So in this triangle, we're asked to work out angle M. You can use any letters really. So the first thing we need to do is understand what angles we've been given. So we've been given 40 degrees and we've been given 90 degrees. So we'd add those two together, and as it shows the methodology down here, and that gives us 130. And you might remember, excuse me, you might remember from the previous video that 180 degrees, from the previous slide, 180 degrees is the total inside the triangle. So once we've taken away 130 from 180, we know then that we're left with 50 degrees. So what does M represent? It represents 50. Moving on to the develop section. This is going to look at some quick fire questions. You are allowed to refer back to the learn section if you can't remember, and that's fine. So let's have a look at question 1. What type of angle is an angle that is 185 degrees? So you might remember that an angle that is over 180 is referred to as a reflex angle. So that's the name of 185 degrees. Okay, so it's slightly more than a straight line. Number 2, how many degrees are there between 12 o'clock and 3 o'clock on a clock face? So try and picture that. 12, of course, is at the top. 3 is in the middle on the right-hand side. And if you had, I'm just going to draw it just very quickly. If you had that pointing, for example, at 12, that pointing at 3, it's asking how many degrees is that, and what do we call that angle? We call that a right angle, and that, of course, is 90 degrees. So it's called a right angle. Number 3, what type of angle is an angle that's 30 degrees? But of course, it's nice and small, less than 90. So we call that an acute angle. And I'm just going to write right angle here. So this is how you would need to record down the answers here, nice and neatly. And then, of course, you can mark it and double check it only once you've done all the questions, though, of course, on here. Go through, give it a nice tick if you've got it correct. In a regular pentagon, what is the total of the interior angles? Now, we're going to need that formula again, so I wonder whether you can remember that. So it's n, take away 2, times 180. And that will give us the interior angles of a regular pentagon. So how many sides has it got? Well, it's got 5. So 5 take away 2 gives me 3. So it's 3 180s. Some of you might be able to do that in your head. If not, you can use this method. 3 times 0 is 0. 3 8s are 24. 3 times 1, add the 2, gives you 540. So how many degrees inside a pentagon? When you add them all up together, it's 540 degrees. What type of angle is an angle that's 164 degrees? Well, that'll be an obtuse, because it's bigger than 90 but less than 180. In a supplementary angle, one angle is 17 degrees. What is the other one? Well, you might remember a supplementary angle is going to add up to 180. So if we subtract 180 or 17 from 180, we're going to get our answer, which is going to give us 163 degrees. Moving on now to some more pictorial examples. So again, going to use your knowledge that you've hopefully learnt before. So we've got 85 and 45, and we've got to work out angle A. Now it's not necessarily always drawn to scale here. So the first thing we need to do is add together 85 and 45, because those are the angles that we've been given already. So that gives us 130. And then we need to subtract 130 from 180. And I'm sure you can all do that in your head to give us 50. So the missing angle, all those angles are actually different, but they do total, of course, 180 degrees. Question 8, what is the value of Q? Now, in this instance, we've been given one angle, which is 42 degrees, and then we've got to work out the Q's. So the first thing to do is 180 subtract 42. So you could subtract 40 first for 140, and of course that gets you 138 degrees. Now, we've got two angles here, so we're going to need to do 138 divided by 2. So you can do it as short division if you like. So 2's into 1 doesn't go. 2 into 13 goes 6, remainder 1, 2 into 18 goes 9. So each angle, or the value of Q, is 69 degrees. Moving on to number 9, can you work out the value of P? Now, when you've got a circle, we're talking about 360 degrees in total. So let's see how many sectors we've got. We call these sectors. They look a little bit like pizza pieces, but divided up the circle into sectors, and there are 6 sectors. So the calculation we need to do is 360 divided by 6. Now, if you know your times tables well, you'll know that 6 60s give me 360. So what's the value of P? It is 60 degrees. The last question here is question 10, and we need to work out the angles A and B. Now this is actually quite simple, because we know that angle A is actually the same size as this angle over here. And the way we know this is because these lines here that have been drawn indicate that the sides and the angles are equal. So we know that's 96 for A, and likewise on the bottom of the trapezium you've got 84 degrees, so that means then that B is also 84 degrees. Now if you were to add all those angles up together, it would of course make in total 360 degrees, just because that is of course a quadrilateral. You don't need to do that, so the answer is A 96 and B 84. Right, moving on to the next part of this review video, we're going to be looking at lesson 25 and focusing on perimeter and area. Just to help you understand some of the formula that you need to use when you're working out things like triangles and parallelograms, there is a useful section in the Learn section which just goes through some of those formulas with you. So just having a look at this page, we've got triangles. In order to work out obviously the area, we do half the base multiplied by the height. Parallelograms, we work out base times height. And with the trapezium, we first of all add together lengths A and B, which is kind of the top and bottom lengths. Then we halve it, and then we multiply it by the height. Now, what we tend to find with the 11 plus is, certainly for things like triangles and squares and rectangles, those are formula that you should know. However, with the parallelogram and trapezium, they are very likely to give you those if you require them. So they would actually give you those formula in the exam, so you don't necessarily need to know them off by heart. But certainly a good idea if you can learn them. You'd be very useful, of course, even later on past the 11 plus. Right, we're going to have a look at the develop section now. So the first question is, what is the perimeter of a rectangle that measures 6 by 2? Now, what you can do here is you can draw your diagrams. So if we have a little look, if we were to draw that out, we've got a rectangle, and we label up the length. So we've got 6 meters, 6 meters, 2 meters, and 2 meters. So if we were to add those up, because remember we're doing the distance all the way around the outside, that's what it means by the perimeter. Sometimes you can obviously get confused with area, so sometimes I'd underline that word to help you. So if we add up all of these, we're going to get 16 meters. Now the way you could do it is to add a width and a length and then just double it. So you could do 6 meters plus 2 meters, and then of course that will give you 16 once you've doubled it. Number 2, find the area of a square with a side length 9 centimetres. Now the fact it's a square indicates to us, of course, that the sides are all equal. So if we were just to sketch that out, we've got our square here. We know that the 9 centimetres length is going to be the same for all 4 sides. So in order to work out the area, we're going to do length by width. In this instance, of course, as I say, they're the same length. So we do 9 times 9, and that will give us 81 centimetres squared. That's important, of course, we add in the squared sign. Number 3, the perimeter of a square is 28 centimetres. What is the length of one side? So again, it's helpful to know that it's a square. So we're going to actually divide 28 by 4. and that will give us the length excuse me, of one side. So that's 7 centimetres. Question 4. Calculate the area of a rectangle with a length of 15 centimetres and a width of 6. Again, I'm just going to sketch this out for you. So in order to find the area in a rectangle, we do the length times the width. So 6 times 15 gives us 90. And it's in centimetres, so that'll be centimetres squared. Moving on now to question 5. If a regular hexagon, now regular will mean that all the sides are the same length, it has sides of 8 centimetres, what is the perimeter? So this would mean us doing 6 times 8. So we're doing the perimeter, we're doing the distance all the way around the outside of that hexagon. 6 times 8 gives me 48 centimetres. Moving on to number 6, find the perimeter of this triangle. So again, we've got to add up all the distances. Just got to be careful here, but I would complement the 6 metres and the 4 metres together. So that would enable me to get 10 metres. And then we're going to add 3 more on. And the answer would be 13 metres. Sometimes what will happen in the 11 plus is some of the answers then, once they're written in a certain unit, might need to be converted. So it's worth knowing your equivalent values. So what is the area of this triangle? Now, we are going to get a little bit algebraic here because we don't actually have any numbers. We've just got the letters. So it says PM and QM. So you might remember earlier we talked about having to half the base times the height. So what we're going to do is we're going to say half, and then in brackets, because this would be the bit we would do first, we're going to do Q multiplied by P, whatever those units might be, and that will be in metres squared. So multiply them and then halve it will give us the area of that triangle. Question 8. If the side of a regular hexagon is W and the perimeter is 48, what is the value of W? So we know the total distance around the outside is 48 centimetres. So we're going to do 48 divided by how many sides a hexagon has, which of course is 6. And that will give us the length of one side, which of course is 8 centimetres. So W equals 8 centimetres. Moving on now to question 9. The area of this rectangle is 50 centimetres squared. So what is the value of L? Now the way that you can work this out is to say, if I've got to say the area of this rectangle is 50 centimetres, then what do I times by 2 to give me 50? So in this instance it will be 25 centimetres for the length, because 2 times 25 gives me 50. So the length of L is 25 centimetres. Question 10, this is the last developed question here. The area of this square is 9 centimetres squared. So what is the value of T? So if the area, the space inside, and we know it's a square, we're going to need to do 3 times 3 to give us 9 centimetres squared. So T, well, the value of T is 3 centimetres. Looking next at the time test, test 17 on page 123. This again follows on from what we've just looked at with the perimeter and area, but these are more based around sort of word problems under those topics. So let's have a look at the first question. Find the area of a square whose perimeter is 24 centimetres. So again, it's useful to know when it's a square, because we therefore can do 24, because we want to find out the length of each side. We divide that by 4 to give us 6 centimetres. So the length of each of the sides of the square, so again if I was just to sketch it out, are 6. And then in order to get the area, we multiply the length by the width. So we're going to do 6 times 6, of course, to give us 36 centimetres squared. So the answer would be D. Question 2. If the area of a rectangle is 60 centimetres and the length is 10, what is the width? So again, we know that the length times the width will give us the area. So if we've already got 10 centimetres for one length of the rectangle, then the answer will be 6, because 6 times 10 gives me 60. Now again, if you just want to look at that from an illustration perspective, they gave us the length, which was 10. We now know that we need 6 for the width, because 6 times 10 gives us 60 centimetres squared for the area, but the width we needed to work out is 6. Question 3. What is the perimeter of a rectangle with a width of 7 centimetres and a length of 11? So again, if you want to sketch this out, we've got 11 for our length, 7 for our width, and we're now going to add these up together. Now you might remember in the previous section we talked about what would be a quicker way of doing this rather than having to add up all of the measurements. Well, if we do 7 add 11, which is 18, and then we double it, we'll then get our answer. So 7 and 11 is 18, double that gives us 36. Slightly quicker way of doing it. The area of a square has sides length of 12 metres. So again, we're going to do 12 times 12 to give us 144 metres squared. Moving on to question 5. What is the perimeter of a regular heptagon? So knowing your shape here is important, how many sides things have. So heptagon has 7, that has sides 9 centimetres long. So again, with the perimeter, it's the total distance all the way around the outside, but we can do 7 times 9, which will give us 63 centimetres. And that will be the perimeter of the heptagon. Moving on to question 6. Find the perimeter of this triangle. So remember, we need to do half the base times the height. That will give us the area. But for the perimeter, we need to add all the lengths together. So in a triangle, it'll be 3 times whatever your lengths are. So in this instance, of course, it will be W. And that will give us the perimeter. So let's have a little look. We could look for 3W, or we could look for W, add W, add W. And of course, as you can see there, the answer will be C. Question 7. What's the area of this triangle? And again, if we refer to what we just made, notes we made up there, we're going to do half R times Q, which of course is the height. So half the base, which is the R, times Q. Now, when we actually write letters together, that indicates that we're going to multiply them. So we can actually shorten this notation to half RQ. And can you see that anywhere? Yes, you can. We've got that as C. So what is the area of this triangle? It's half RQ. Question 8. If W is 4 centimetres, I'm just going to replace that there on that diagram. What's the area? So we're just going to multiply them together. So it's 8 times 4 gives us 32 centimetres squared. For B. Question 9. If the area is 100 centimetres, what is the value of L? So we know that this is 100 centimetres squared for the actual area. So we need to think of, well, what do we times by 5 to make 100? Well, of course, that is 20. So the answer is C. 5 times 20 is 100. Question 10. If the area of a triangle is 25 centimetres, what is the value of x? Now, to work this one out, we're going to do the area of the rectangle would be 50 centimetres. This would be halved for the triangle to be 25 centimetres. Therefore, the length is 10. As 10 times 5 is 50. And of course, we then need to halve that amount. So the answer is E. Question 11. An ant walks all the way around the edge of a rectangular patio tile. If the tile measures 0.6 by 1.2, how far does the ant walk in centimetres? So the way to work this one out is to add together 0.6 and 1.2 and then times it by 2. So 0.6 plus 1.2 is going to give me 1.8, and then we're going to double that, which gives me 3.6 metres. So how far did the ant travel? 3.6 metres. But if we look at our answer options, you'll see that's not actually there. So we're going to need to convert 3.6 metres into centimetres. And the way to do that is to multiply by 100. So 3.6, just do my jottings up here, times 100 is going to give me 360 centimetres. So the answer is D. Just moving on to the last few questions now. A flower bed has a total perimeter of 24 metres. If the length is 8 metres, what is the length of the two widths together? So both lengths total 16 metres. So 24 subtract 16 gives me 8. So the two widths total together 8 metres. Question 13. A luggage tag has edges of 6 centimetres and 3 centimetres. What is the area? In millimetres. Excuse me. So the first thing to do is do 6 centimetres times 3.5, but we're going to actually convert those into millimetres. So you should know that there are 10 millimetres to every centimetre. So we're going to have 60 millimetres, which is equivalent to 6 centimetres, times 35 millimetres. And if you multiply those together, you get 2,100 millimetres squared. So again, conversion is really important, knowing how many centimetres in a metre, knowing how many millimetres in a centimetre. So do learn those really key facts. Question 14. The side window of a car was a parallelogram in shape. If the base was 0.5 metres long and the height was 0.4 metres, what was the area in square metres? Well, again, you might remember to find the area of a parallelogram, we're going to multiply the base by the height. So in this instance, 0.5 times 0.4, because that's the length and the width, the length and the height. We're then going to multiply those together, and that will give us 0.2 metres squared. Question 15, the last one here. Amy has a rectangular rose garden that measures 8 metres by 12.5. One bag of fertiliser can cover 16 metres squared. How many bags will she need to cover the rose garden? So the first thing to do here, obviously to find the area, is do 8 metres times 12.5. And that will give you 100 metres squared. So that's the total. But the bag can cover 16 metres. So it's really 100 divided by 16. Now that may not necessarily go in exactly, but it will be 6 1/4, or if you like, 6.25. So therefore, 6 will not quite be enough, nearly, but we're going to need to get an extra bag. Therefore, 7 bags will actually be needed. Thank you very much for watching this video. Hope you found it useful. Bye-bye.